Okay, we've got here 2 points on a grid, and we've identified the coordinates of these points as well. I've taken the coordinates and I've plotted these 2 points right here for us to work with. What I want to do is try to determine the slope of the line that these 2 points lie on. And we don't see a line there, but there's an imaginary line. Let's imagine that they're connected and that line goes forever in both directions. And if that's a straight line, then there's an equation for it, a linear equation for it. We don't know that yet. We're not even going to worry about the equation. I just want to identify the slope of these 2 points. And there's a couple of ways that we can look for that. A couple of ways that we can identify that. First, let's look at the graph itself. Since we plotted these points on the graph, we can calculate the slope by using the rise over the run, or counting the number of units up and the number of units over it would take to travel from one point to the other just along the grid lines, right? So if these were roads and we had to drive from this point to this point, we couldn't drive through these, yards, and maybe there's trees in the way and so forth. We don't know. These are blocks, right? So we'd have to drive along the road. And if we wanted to take as few turns as possible, we would go up these 2 points and over these 1, 2, 3, 4, 5, 6, and that's going to help us find our slope. So by going up 2, that's considered a rise of 2, and going over to the right 6, that would be a run of 6. So that would be 2 over 6, and we could simplify that to 1 over 3. So the slope of the line that these fall on is 1 over 3, or 1/3. That's how we find the slope. We could also look at it like this. Here's the rise, 1 over the run, 3, 1, 2, 3. There would be another point on the line right there. From here, we would go 1 over 1, 2, 3. It's 1/3, and we end up on that point. So any 2 points on this line, if we use that rise over run formula, 1 over 3, we'll get from one point to another. Now let's look at the table over here on the left side of the screen. We've got the coordinates of these 2 points. And if we look at the difference between the y coordinates, 6 and 4, the difference is 2, right? 6 minus 4 is 2. And the difference between these 2 coordinates, -2 and 4, that's the distance between those numbers on the number line would be the difference. And the distance is 6. So again, we have that 2 over 6. If we take the difference between the y coordinates and divide it by the difference between the x coordinates, we get the same thing, 2 over 6, or 1/3. So that's another way we can find the slope of a line. That's the vertical change over the horizontal change that's mentioned in the textbook on page 90. That's what they're talking about. Okay, that's all that we have to do to find the slope. I want to now use that slope to put another point on this line. So I know that the rise over run will find any 2 points on this line. So I could do a rise in this direction of 1, 1, 2, 3, and I could put a point right there. So that point right there, the rise over run from this point would end up right here. And that would be 1 from the x-axis and 5. So if I type in over here a 1 and a 5, I get a point right there where we just identified. Let's put one over here too, right? So here's that rise over run. So if we imagine there's the rise, because we're going down now from right to left, 1, 1, 2, 3. This would be another place where that point would be, right? Or from here, we would go the rise up 1 over 3 this way, right? So if you're going from right to left, you're going down. If you're going from left to right, you're going up, and that means it's a positive slope, a positive 1/3 slope.